Hello everyone, so today we're going to review together on knee ankle foot roses. So in this review session, we're going to divide it into two parts. So this first part will be covered in this first video and the second part will be in the next one. And here's our outline. We're going to go through the anatomy review about the knee joint, and then we're going to go through the pathological gait of the knee as well as the deformity around the knee. One of the core principle of KFO and the KO, including the three-point resting system on the common knee deformities and common orthotic knee that we can be prescribed for the patient who might need the support around the knee and the knee, ankle, and foot. About the structure of the knee, we need to think about what are the bones that compose the knee joint. You might know that when we talk about knee, most of the time we will think about the patellofemoral joint and the tibiofemoral joint. Actually, the patellofemoral joint is not really like the main joint that provide motion around the knee. So the main joint that provide motion around the knee is the tibiofemoral joint. So this tibiofemoral joint is the type of the synovial modified hinge joint because this provide more than just flexion and extension. It also provides some rotation, which is advantageous for the knee joint because it will be give the ability of the knee go to screw home connection in order to provide like stability for the knee. When we're talking about the joint, like I mentioned earlier, the joint of the knee, we can be talking about the patellofemoral joint and tibiofemoral joint. So for the patellofemoral joint is the gliding joint is the gliding joint between the patellar surface or the trochlear glue with the composition of the patella. Okay, is the posterior facet of the patella here. So it will be interfaceted with the patellar surface or the trochlear groove. And then we have another one is the hinge joint. Is a modified hinge joint that it's the main joint that provide like flexion and extension motion is the tibiofemoral joint. So because of the shape of the tibia and femur are not really matched to each other, if you look it from the sagittal view, so you look at the shape of the femur, this is anterior and this is posterior. So the shape of the femur at distally it have this convex surface, okay, at the condyle of the femurs. And when you look at the tibia, so this is anterior and this is posterior. So you look at the tibia, you have this flat surface of the tibia plateau. So if you're matching this between the femur condyle over the tibia plateau, the shape of the tibia and the femur is not really matched to each other. So it will have this space shape, which is like have this space shape and only small contact area around the condyle of the femur attached to the tibia. So this will be filled by the cartilages. So the cartilage of the meniscus is very specifically found in the knee joint. It will be filled between those gaps. So the meniscus have the advantages of providing like a friction reduction between the bone and the bone. Is fill the space and reduce the shock. So because of the space is not faced together, so the weight distribution from the femur to the tibia is reduced. So in order to improve the ability to distribute the weight throughout the surface of the femur and the tibia, so meniscus will be act as like a space filler between those gaps. And it also improves the stability around the knee because of it will be like a pocket that lock the femur on the plateau or the tibia. Okay. Now we're going to go through a little bit about the ligament, common ligament, the main big ligament around the knee joint. So what you need to do is know is the anterior cruciate ligament. So the anterior cruciate ligament is the ligament that connected from the tibia plateau to the intercondyle of the femur. So this anterior cruciate ligament, as the name suggested, is to provide like anterior stability over the tibia move over the femur. So for the posterior cruciate ligament is across the anterior cruciate ligament. So this posterior cruciate ligament is provide like the opposite function, is provide like the posterior stability of the tibia over the femur. Then we have the lateral collateral ligament. As the name suggested, it stay at the lateral side of the connected from the condyle of the femur that's connected to the lateral condyle of the tibia as well as the head of fibula. Sometimes it can be called as the fibula collateral ligament. So this ligament is, as the name provide like the stability over the rest stress. And you have the medial cruciate ligament, is stay at the medial side that connected from the medial condyle of the femur go to the medial condyle of the tibia. So this sometimes can be called as the tibial collateral ligament. So this is provide like the medial stability to the knee or the stability over the valgus stress. Then you have the oblique popliteal ligament. So the oblique popliteal ligament is the originated from the membranous and provide like the posterior strengthening to the knee joint. So this is like a extension and arising from the semimembranous muscle, and it provides more stability to control like the movement of the tibia toward the posterior of the femur, and is connected together with the joint capsule. Then you have the iliotibial tract. So the iliotibial tract is like the tendon of the tensor fasciolata muscle. So this tensor fasciolata muscle is a very short muscle at the lateral side that can help to do some abduction. Okay, so this is like a connected band that connected from the tendon of the tensor fasciolata distally and connected to the lateral attachment point of the iliotibial band. Okay, so just proximal to the tibial condyle. Okay, so it's connected over that lateral side of the tibia. So it's provide like a support to the lateral side of the knee and control the rest stress test. But it can be relaxed in the position, especially it will be more tightened when the knee is extended, and it can be more slack or loosened when the knee is become flexion. Then we have the last one is the ligamentum patellae. So the ligamentum patellae is the actually is like the extension of the quadricep tendon that across the patella, and then it's connected from the patella to the tibia. So that's why it's called this part as the ligamentum patellae. So it's also provide like the anterior support to the knee joint. It can also provide like a protection of the anterior surface of the knee. When it comes to the movement of the knee joint, we need to know that the knee joint is the modified hinge joint. So as the name suggested, the synovial hinge joint is provide mainly flexion and extension motion. Even though it's a modified hinge joint, but the only range that can be measured clearly is the flexion of the knee. It's approximately from 0 to 140 to 160 degrees, depending on the obesity, the mass of the soft tissue, or the muscle of the person that we're going to measure the range from. And the extension is started from 0 to 5 degree, and other than that we consider as an hyperextension. So when we're talking about the movement of the knee, we need to know that which muscle that doing those motion. So for the flexion is working because of hamstring muscle, and the extension is about the quadricep muscle. What is special about the quadricep muscle is that we have the quadricep muscle mechanical advantages that because of the patella. So because of the position of the patella is run underneath the quadricep tendon. Okay, so this will provide like a additional distance between the knee joint itself to the quadricep tendon. So when the distance or the lever arm between the quadricep tendon is greater compared to the one without the patella, is increase the strength of the quadricep. So because of these mechanical advantages, because of this extensor lever arm, we able to increase about 30% of the strength of the quadricep tendon just by the additional lever arm that we have in the patella. So in the vice versa, in reverse, if you lost the patella, you might lose about 30% of the total strength of the quadricep, which means you need to work about 30% harder to control the same amount of the knee flexion movement, or work 30% harder in order to provide the same amount of stability that you might have with the patella. The patella itself is able to glide approximately 7 cm to proximal and to distally, while it can be glided to the medial and lateral over the trochlear groove approximately about 1 to 2 cm in the mid or lateral direction. When we talk about the femoral tibial angle, also known as the Q angle. We need to talk about the angle between the femur and the tibia. So this angle is measured between the anterior superior iliac spine, and then go to the midpoint of the patella, and from the midpoint of patella we draw another line to the tibia towards T. So then we connected the two lines together. So the angle between these two, we call it the femoral tibial angle or Q angle. So in the adult male, you will have approximately 170 to 175 degree of the Q angle, while in female it's approximately 170, which means the female have more Q angle compared to the male. So we need to know about this because we need to know that the Q angle can be reused, so it can be around 0 degree when the baby is in age of the 18 to 24 months, and is increased gradually until it becomes the vulgus position when the baby reach to the age 3 to 4. It means like the young children. So we need to know about this when we make like a KFO or KO for the patient. We need to consider about their age, so then we can provide like appropriate Q angle for the patient, so then we don't create like the unwanted varus movement for the patient, or we don't create another deformity which is should not be presented without the orthosis. Then we need to talk about the screw hole mechanism. So the screw hole mechanism is the mechanism which provides the stability to the knee joint. So this mechanism is happen when the knee is go to the full extension. Is approximately is between the 30 degree of the end range. So the knee is start to extend it, and then the anterior cruciate ligament is become tightened, and then due to the further extension, because of the medial condyle of the femur have a lesser articular surface compared to the lateral condyle of the femur, so then the femur is rotate laterally, so making compression to the meniscus and making all the posterior cruciate ligament, medial and lateral collateral ligament become tightened and blocking the knee in extension position. So in order to unlock this position, the popliteal muscle need to internally rotate the knee in order to unlock the screw hole mechanism and let the knee become flex again. So now we come to the gait cycle and the pathological gap. But before we move on, I want you to review about the muscle origin and extension and action of the muscle that is have like the influence around the knee. It's not only about the quadricep and hamstring, but also around the muscle that acting on the ankle and the hip joint that have the influence on the knee. For example, like triceps surae, like a soleus, is not really across the knee joint. Is origin and insertion is below the knee joint, but it had the influence on the knee joint in mid-stand in order to control the tibial forward progression and knee flexion in the from the loading response to mid-stand. So I want you to review all muscle that can be have the give you more understanding on how the normal gaits work, so then you can use it as a base guideline for how does this muscle affect to the pathological gait on the knee joint. So come to the gait cycle. As you might know that one gait cycle is counted from the initial contact or heel strike from one side to the same side initial contact or heel strike. So we call it one stride. So one gait cycle is equal to one stride. So one stride length is equal to one step length. Okay. So the period can be divided into the stand phase and swing phase. So stand phase is any time that the leg is touched to the ground, and swing phase is any time that the foot or the leg is not touched to the ground. So it can be divided into the ball support or single support. So when we're looking at the subphases of the gait, you have the initial contact, or you can call it heel strike in the old term. Then you have the loading response, or you call it foot flat in the old term, and you have mid stand, which is the same, and then you have terminal stand, which is the heel off, and you have pre-swing, which is toe off. You have initial swing, which is called as the acceleration, and then you call it mid swing, the same, and then you have terminal swing, which is called deceleration. So for the main task for this phase of gait, as in this slide so is that for the initial contact and loading response is mainly is used for the weight acceptance, and then for the mid stand and terminal stand is used for the lingual limb support, which means that only one side of the leg that's tied to the ground and all the weight is supported by one side of the leg. And then you have the swing limb advancement. So as the name says, swing limb advancement is mean that you progress the limb forward by swinging it forward. Okay. Then we need to think about what happens if there's a deviation happen to the knee or other part of the joint due to the abnormality of the muscle that has not been functioned properly, that like it's supposed to work in the normal gait. So we tend to talk about now we talk about the weak knee extensor on the gait. So if the weak knee extensor, how does it affect on the gait cycle? So the quadricep muscle are the primary knee extensor. So in loading response is control the knee flexion caused by the ground action force passed posterior to the knee joint. And in the first half of mid stand, it's also have to extend the knee against the ground action force, which is the remaining posteriorly to the knee joint. In pre-swing, it's work to control the knee flexion caused by the ground action force passed posterior to the knee, and in initial swings, it's control the knee flexion caused by the momentum of the hip flexion, which is called pendulum action. And in terminal swing also work to extend the knee and make sure the knee is ready for the initial contact. So this is like the main muscle that work a lot in the whole gait cycle. So what happens if the knee extensor become weak or unable to perform its task? So the knee can go to hyperextension. That would be the compensation caused by the instability knee. So when the knee is go to unstable position, so the patient might not be able to walk or put any weight on it. So the patient might try to extend the knee by avoiding it. Okay, use the anterior trunk bending in order to manipulate the ground action force in relation to the center of gravity pass anterior to the knee, and over the duration over the duration or long period of time, the knee will tend to hyperextension due to the abnormal movement and position of the ground action force in comparison to the knee. So this is like the complication caused by the knee extensor weakness. Then what happens if the knee flexor become weak? So the hamstring are the primary hip flexors. Knee flexor. So it's work at the terminal swing and initial contact. So if you look at the terminal swing and the initial contact, so this hamstring muscle is will work in order to prevent the knee go to the terminal impact, and in order to make sure that the knee will not go to hyperextended at the end of the pendulum action. So if the knee flexor are weak, it will cause the knee go to hyperextension in initial contact, and it will be lost control over the knee joint capsule in the extension motion. So that's what will happen is if the knee flexor are weak. So now we talk about the hip extensor. Okay, so if the hip extensor is weak, what might happen to the gait cycle? So the hip extensor are working in loading response. So it's work against the ground action force, which is passed anterior to the hips, creating that hip flexion motion. So if the hip extensor are weak, the patient might be not able to control the hip flexion motion. So the patient might use like the upper body in order to compensate to this weak hip extensor by posterior leaning of the trunk and reduce their step length in order to reduce the movement and the distance between the ground action force and the hip. Okay, so in terminal swing, the hip also extensor also have to decelerate the hip flexion motion, which is make sure that the leg are ready for the initial contact. If the hip extensor are weak, so the patient might not be able to control this, and the patient might be cause more hip flexion and due to abnormal initial contact in the early stand. So in this case, the patient might use the similar compensation by posterior leaning the trunk and make sure that the hip does not go to flexion aggressively. So what happens if the hip flexor is become weak? Okay, so the hip flexor are working at the terminal stand and pre-swing as the current action force are passed posterior to the hips. Okay, so in the terminal stance and pre-swing as the current action force are posterior to the hip, so it's create like a extension motion. So this need to work to control the hip flexion motion. Also, not only that, it need to also swing the limb forward in order to provide like a pendulum action to swing the whole leg forward. So if the hip flexor become weak, so the patient might not be able to control the movement caused by ground action force, let alone the pendulum action that need to be actively in order to swing or advance the limb forward. So the patient might be use upper trunk movement, like try to sway the hip or sway the trunk in order to bring the limbs forward, or the patient might use other compensatory gait for in order to clear the leg from the ground. Okay, now it's come to the pathological posture. So now we look at the knee joint itself. It's not only got the pathological posture because of the knee pathology itself or knee deformity itself, but also can be caused by the proximal joint. In this picture, we look at the normal standing posture, whereas the center of gravity, the line of it is fall just right under over the base of support. But in the second pictures, you can see that if the patient has hip flexion contracture, it means that the hip joint cannot be extended as normal. It's in the flexion position. So in this position, without any compensation, the ground action force in relation with the center of gravity will fall posterior to the base support, which is cause the posterior instability. Okay, so the patient will fall backward. So in order to compensate to this deformity, the patient will or the people will flex their knees, okay, in order to make sure that the center of gravity is fall over the base support. So this is make the ankle joint become dorsiflex, the knee is become flex, and the hip also in flexion position in this compensation. So this is what the patient might do, and it's not a good posture to stand with because you need to work your quadricep muscle very strongly because of the greater distance here, so that you might get tired quicker and screw home mechanism cannot be worked to provide like a stability for the knee. So this would be the pathological posture if the patient have plantar contracture. So the plantar contracture when the patient stand with the foot flat on the floor. So this will be preventing the tibia to progress forward. So this means that the tibia cannot be in the vertical position as the normal people would do. So then it would be lean posteriorly. So in order to compensate for this, the patient can either bend the trunk forward. Okay, so when they bend the trunk forward, it means that they maintain the center of gravity over the base of support, or they can do the knee hyperextension, because if they don't do that, then center of gravity will fall posteriorly. So if they do that over the trunk forward anterior for a long time, this will create this distance, okay, between the ground action force or center of gravity line to the knee joint. So it will increase the hyperextension on the knee, and it will cause the knee go to instability anteriorly. Okay, and then another one, to compensate this, the patient might do the false dorsiflexion on the metatarsophalangeal joint. So when the patient do this, it's simply that it means that they maintain the ankle in the plantar flexion position while they do the dorsiflexion on the metatarsophalangeal joint by allowing the knee go to flexion and the hip go to flexion, and maintain the position of the center of gravity over the base support. So when the patient standing on the extension or raise on the metatarsophalangeal joint, it means that the hip and the knee are both in flexion, and it is need to require a very strong triceps muscle in order to control this position of the knee and the ankle. So if the patient have the weak triceps, the patient might not be able to stand in this position. So these are the common 3-point pressure system that we can use around the knee joint. So if we look at this first picture, this is the 3-force system that used to control the knee flexion movement or used to correct knee flexion structure. So in order to provide the stability to the knee, we want to provide like one force anterior to the knee, posterior directed force on the knee joint. It can be split just proximal, just distal to the knee joint if you want to avoid the over pressure on the articular surface itself, and two stabilizing force from the posterior side as the antidirective force, one at the proximal outer side and one at the posterior distal outer tibia. So when you provide this force, make sure that this two joint is not crossed by the force. So if you cross two joints, you will create another movement. So in this next system, is the system used to correct the knee hyperextension or knee extension motion. So when the patient have a knee hyperextension, you want to use this force system to correct it. So one force is you want to place it from the posterior of the knee, and then the stabilizing force is at the anterior proximal and the distal anterior of the tibia. So when you provide this force, you will provide a counteract to each other and provide like a flexion movement to the knee. Then you have this force system is used for the valgus control. So when a patient has the valgus deformity and you want to correct it, so you can use one correction force at the medial side of the knee joint and two stabilizing force at the lateral side of the upper thigh, and another one is at the lateral side of the tibia, distal of the tibia. So when you use this force system, you need to make sure that you don't provide any excessive pressure on the medial side of the knee, because it's very sensitive to pressure. So you can split it to proximal and just distal to it if the force is strong enough. If you need the very strong corrective force, then we might use like a knee strap in order to have this one. So at the last one, you have this force system used to correct the varus deformity of the knee. So it's the opposite of the valgus deformity. It's the knee joint need to provide like a valgus stress to the knee. So you need to provide one force to force the knee from the lateral to the medial, and you can split it to one proximal to the and one distal to the knee joint in order to split the force. So you will provide like a valgus stress to the knee. Another one is you provide like medial proximal of the thigh section, and one is the medial distal of the tibia section. Okay, now we come to the prescription principle of the knee joint. So I want, in order to prescribe the knee joint, we need to look at the design itself, whether it's a hybrid orthosis, is it a conventional orthosis, or is it a custom-made plastic orthosis. So this is the picture of the conventional orthosis. This is can be like a hybrid that you can use. Some part is like more conventional, another part is you connect it with the plastic or pre-break material. Okay, and then you need to think about the weight bearing mechanism, whether you want to use like the axial weight bearing, you want to use compressor pressure, or you want to use like the ischial weight offloading. Okay, and then you need to think about the knee joint mechanism, like what type of knee joint that you want, that we're going to talk a bit more detail in the next part. Also the ankle joint, you need to consider what type of the ankle muscle strength or ankle deformity that have around the ankle, so then you can use it as an influence. And the principle for the ankle mechanism is can be referred to the ankle orthosis, ankle foot orthosis. And for the foot plate, it also can be designed depending on what type of movement that you want. It's either metatarsal length that you can provide like extension of metatarsal length heel joint, or can be full length is to provide like a rigid base plate for push forward. Okay, so depending on the function that you want, you can prescribe different type of foot length and the ankle joint for the patient. And other consideration like the force system, alignment of the patient, and decompensation, and the strap usage. Like depending on the deformity, you might use different location of the strap, different type of straps, and different type of the compensation, either modification on the orthosis, like for the LLD or for the deformity control, so on. So when we're talking about the function and of the mechanical knee joint is used to support the body weight. So when the patient have lost the ability to weight transfer from the axial weight bearing, so the external sidebar can be used to support the body weight. Especially this is when you look at the ischial weight bearing, KAFO. This means that the weight is supported not only from the axial load bearing, but you will be transfer the load from the upper body to the ischial seat, and then to the plastic cell, and to the knee joint itself, and then to the plastic cell again, and to the ground. So this is how does the knee joint can support the body weight. Not only that, if the patient have the very weak muscle and cannot be controlled in any motion, so then the knee can be used as like a lock knee in order to support the body weight itself. And then it can help to increase the efficiency of walking and preventing pathological movement. Like if the patient have like a valgus instability or varus instability, so then you might prescribe the knee joint which allow the free motion of flexion and extension while stopping the valgus or varus movement in the coronal plane. So it will be eliminated all the unwanted movement in the coronal plane. Another one is maintain a proper alignment of the joint. So again, if the joint is in any deformity, for example flexion contracture, and you don't want that contracture to develop more further, then you want to keep it in some amount of flexion and reduce it to the extension motion, then you can use the joint with the adjustable angle like a dialogue and fan lock in order to correct the alignment and maintain it in the proper position. Another one is to allow the full range of the joint when required. So this is depending on type of joint that you use. So if you need a full range of motion, you can allow like offset knee joint, which is control like only the ML direction, but you still can allow the knee go to fully flexion and extension as needed, on only provide some stability in addition to the quadricep muscle by the contraction force influences. Another one is to maintain the correction when it's in the therapeutic use. So this is mean that if the patient working with the physiotherapy treatment or the hydrotherapy treatment, and then they might need to use like the additional support from the orthotics in order to use it like a neoprene or like a reminder when they do exercise. So this is can be used to provide like a support for the patient from the knee, orthotic knee. Now we're going to look a bit about the characteristic of the knee joint. So when we're talking about the orthotic knee joint, we need to know these two words. One is the modular knee joint and integrated knee joint. So what is the difference between the modular and the integrated? So it's not about which company that you order it from or when it's the latest model that you the design was discovered or was designed, but it's about the system and the structure of the component of the knee joint itself. So the word modular knee joint is mean that the component of the upright and the joint itself is can be separated. So it consists of the proximal and distal joint surface, okay, that can be connected to the upright, and this joint is independently can be removed from the proximal and distal upright. So this is very advantageous if you want to prescribe and play with different type of knee joint, or when the patient is a child and then they grow very fast, so then you don't want to pay for many pair of knee joint, so then you can just use to change the upright. So this is the word of modular knee joint, which means that the joint is have the separation between the upright and the joint. So for the integrated joint, it means that it's just one piece joint. So it means that the upright and the joint itself is just in one piece. So it's connect directly from the upright to the joint and from the distal upright to the joint surface itself. So it's just one piece. It just have the upright and joint surface. It has the advantage of the better cosmesis compared to the modular, and also it's lighter weight most of the time, and increase the strength because of it's just one piece. It doesn't have a bolt or a screw that connect together, so it's less part that need to be maintained, and it can be loosened due to the time. So this one piece is much stronger, and this one thing is difficult to repair. So it means that when the patient grow up or when there's something wrong with the upright, we need to change the whole piece or make a new orthosis instead of changing the joint or changing the upright. So that's it. We come to the end of this first part, and see you again on the second part of the knee ankle foot orthosis.